Hello, welcome to the video. In this lesson, we're going to be looking at section 2.2, where we're going to be solving inequalities using addition or subtraction. Essentially, we are going to be solving inequalities just like we did solving equations. We're attempting to isolate the variable. The only difference is we have either greater than, less than, greater than or equal to, or less than or equal to, and they'll probably ask us to graph the said inequality just like we did in section 2.1. So here again, this is the situation we have for addition properties of equality. All it means is whatever you do to one side of the inequality, you're going to do the exact same thing to the other side, just like you did with the equations. So here it says like, oh, if I add 4 to the left side, if I add 4 to the right side, it still remains balanced. And that is an indicator of what we're going to do when it comes to solving for variables. So in this particular example, we have x minus 6 is greater than or equal to negative 10, and it's asking us to graph it. So this is where we're going to utilize this addition property because we have the minus 6. That means we're going to add 6 to both sides. What that'll do is it gets rid of that minus 6 on the left side, which just leaves me with a variable of x, and I have greater than or equal to negative 4. So when I graph this, I put my negative 4 in the middle, open or close. This is a closed circle situation, and my variable is on the left-hand side of the equality, so I can look at my arrow. It's pointing towards the right, so my arrow shading is going to be going this way. So here's my solution, here's my graph. Looking at these ones, essentially doing the same thing. Everything about questions 1, 2, and 3, you're going to be adding a number. So for number 1, you're adding 2 to both sides, which gives me b is greater than negative 7. For number 2, I'm going to add 3 to both sides, which means m is less than or equal to 8. And here I'm going to add 1/4 to both sides, which gives me 2/4, which is 1/2 is greater than y. All right. The first two, relatively straightforward to graph. I have my negative 7, open circle, shades to the right. For number 2, again, 8's in the middle. It's a closed circle. It shades to the left because if I look at my arrow. In questions 1 and 2, both variables are on the left-hand side. The only one that's different is number 3, the variables on the right-hand side. So what I'm going to do in order to graph this is I'm just simply going to switch around the two sides. I'm putting y on the left, I'm putting 1/2 on the right. And since the inequality is aiming towards the 1/2, I'm going to do that as well over here. So this is just a way of helping me see what I need to shade or where the shading needs to go a bit easier on the graph. It's an open circle, variables on the left-hand side. I got an arrow pointing to the left. That is where I'm going with this graph. Subtraction, same thing with addition. The only thing is now we're subtracting. Trying to keep the inequality balanced, just like what we did with equations in chapter 1. So here are some examples. Here I have y plus 8 is less than or equal to 5, so I got -8 to both sides. This gets canceled. I have y is less than or equal to -3 in this case. I got my graph, put -3 here. It's a closed circle, and looks like the arrow is pointing to the left, so my shading goes to the left as well. For B, I'm going to subtract 1.4 to both sides. So now I got -8 minus 1.4, which gets me -9.4 is less than M. Now, for the graphing portion, I'm going to switch around the two sides of the inequality because I want my variable on the left-hand side. It's just a way for me to identify the shading easier. It's going to be an open circle, and to the right is our shading. Again, these are more examples. I would encourage you to attempt them. If you have any additional questions, please let me know. So here, all right, sorry about that. It says that a circuit overloads at 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. The first part right here, it says write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. So for part A, I have, let's just say X is our potential appliance that we'll use wattage for, and we're going to add it to the 1100, which is what the microwave uses. And we know that 1800 is what it cannot exceed. So in this particular example, we are going to be using the less than inequality because everything on the left-hand side must be smaller than that 1800. Can't be equal to, because if it's equal to, it'll overload. So using subtraction property to subtract 1100 to both sides, X in this particular instance will be less than 700 watts. So that's part A. So that's how we can set that up as an inequality. And then here, if you look in the book, actually, the toaster should be 800 and not 80. So make sure that you make that change in your notes. But for part B, it says, in addition to the microwave oven, which of the following applications or appliances, sorry, can you plug into the circuit at the same time without overloading the circuit? So you have, again, you have the 1800 watts. So essentially, you're taking everything that would be less than 700. So the clock radio would work, the blender would work, not the hot plate and not the toaster. So the the additional appliances that you could use is clock radio and the blender. Here it says, again, the microwave oven uses only 1000 watts of electricity. Does this allow you to have both the microwave oven and the toaster plugged in? So looking at this, you're going to have to rewrite an inequality statement. You have essentially, you're going to, well, they gave you the two pieces of information. I believe the other one was 800 and then 1000. So is it less than, or I'm sorry, is it less than the 1800? So in this case, it's 1800 is less than 1800. Since there is no equal sign below it, this is a false statement. So my answer would be no. I could not use both the toaster and the microwave oven in order, um, I could not use that on that same circuit without it overloading. And that is being able to solve inequalities using addition or subtraction. I hope this helps. Till next time.